What I'd like to do right now is introduce 3 meters to you that we use a lot in our testing. As stated before, we don't make these meters, we buy them off the internet like everyone else. The first one I'd like to introduce is the current cost by Envy. The current cost can be programmed for a monetary value that you pay for power. In Montana, where we are right now, we pay 9.9 cents a kilowatt. So we have this meter set at 10 cents. The next meter, well, let me explain this a little bit. The current cost has a wireless clip that will go around the load, wirelessly transmit from the transmitter to the receiver, where the receiver, programmed at 10 cents a kilowatt, will show us in watts and cost. And you will see this meter cycle from what it costs per day to what it would cost per month. Now, I'd like to say that you wouldn't leave something on 24 hours a day, 7 days a week, obviously, but you need a meter to give you a baseline. The next meter that we're using is the kilowatt by a company called P3. We use a lot of these. This next meter is an EMF meter made by Graham-Stetzer. The Graham-Stetzer meter is the standard of the industry. We also very commonly use a fluke meter for amps, like the P3, but the P3 also shows power factor, and we don't want to overdo it. For this demonstration right now, we're going to use the P3 for amps and power factor. We're going to use the Envy for watts, and we're going to use the Graham-Stetzer for EMFs. The first product that we're going to demonstrate through the meter setup is what we would standardly call the Satic Energy Saver Power Perfect wire-in product. For this demonstration, we have a 5 amp motor, very commonly used in air conditioners. It's a very common air conditioner motor that would actually run the compressor for this test. A Satic unit going through just a regular Belkin brand power strip, so that we can see in volts and amps and in watts and an electromagnetic field what this motor will take to run. So I'm going to go ahead and turn the motor on now. You'll hear the motor. Immediately, our little amp meter is at 4.5, and our power factor, we're going to be at 60 hertz, and our power factor is at 29. Dismal. So only 30% of the electricity we're buying is actually performing work. The extra 70%, besides running up our bill, is going to cause this little motor to get warm. And we can see now that at 10 cents a kilowatt, this would cost about $33 a month. Now granted, we're honest people, you probably wouldn't leave this motor on 24 hours a day, 7 days a week. But if you were, for a baseline, this is what it would cost. Now we're going to add the Satic Power Perfect system to the load, and watch what happens both in amps and in watts. Nearly immediately, we see the amps drop to 1.4. That is a huge reduction. So no matter what that means financially, this motor is going to run better. The power factor is now nearly perfect. Almost all the electricity that we're buying is turning into real work. Next, we can see a huge reduction on the bill. We can see a true economic gain on the bill. Something that I forgot to mention is the EMFs. Let's go ahead and turn the Satic unit off again. let's watch the EMFs climb, the amps climb, and the dollars climb. And as soon as we add the Satic unit to the load again, we're going to see a visible drop on all 3 meters. I think this is an excellent way for you, for your own mind, to truly see how the product works and be able to clearly communicate it to a customer on 3 meters that we're creating a very effective change.